Hello everyone. Topic is Unpivot and Unpivot with Python code and also doing with method. In this code, we start by setting up a Spark session, which is essential for working with PySpark. The session acts as the entry point to interact with Spark, allowing us to create data frames and perform various operations on them. We then define some sample data, consisting of sales figures for two individuals, Alice and Bob, across 3 different months. This data includes columns for their names, the month, the department they belong to, which is sales in this case, and the amount they sold. We create a data frame from this sample data, which is essentially a table structure that we can manipulate using PySpark. After displaying the initial data frame, we proceed to perform a pivot operation. Pivoting in this context means transforming the data frame so that the months become columns, with the sales amounts becoming the corresponding values under each month. This operation groups the data by each individual and their department, allowing us to see their sales figures spread across the months in separate columns. Next, we reverse this process with an unpivot operation, effectively transforming the data frame back to its original structure. This is done by converting the columns for each month back into rows, so we again have a single column representing the month and another representing the sales amount. Finally, we convert the pivoted data frame to a pandas data frame, which is a more familiar format if you're working in Python outside of Spark. In pandas, we use the melt function to achieve a similar unpivot effect, making the data more flexible for analysis. This code demonstrates how to switch between different data formats and transformations, showcasing the power and versatility of both PySpark and pandas in handling structured data. Pivot operation. The first part of the code is focused on pivoting. We start by importing the necessary libraries, including PySpark SQL functions. A function named create_dynamic_pivot is defined, which accepts parameters like the Spark session, the name of the table, the column to pivot on, the columns to group by, and the value columns that will be aggregated. Inside the function, the group by columns and value columns are split into lists for easier manipulation. The dataset is loaded into a data frame from a specified table, and the distinct categories from the pivot column are extracted. This allows the code to dynamically determine which categories will become the new columns in the pivot operation. Depending on the number of value columns, either 1, 2, or 3, the function dynamically constructs expressions to create new pivot columns by summing the values where the category matches the current pivot column. These expressions are then used in a group by operation to generate the final pivoted data frame. This data frame is then registered as a temporary view in Spark, which can be used for further SQL operations within the session. Unpivot operation. The second part of the code handles the unpivot operation. Similarly, we start by importing the required PySpark functions. The create_dynamic_attribute_an_value function is defined to perform the unpivot operation. This function also takes parameters such as the Spark session, table name, pivot column, group by columns, and value columns. The function begins by splitting the group by and value columns into lists, much like in the pivot function. The table is loaded into a data frame. The unpivot operation is simulated using a stack function within a selectX pair statement, which transforms the value columns into rows, creating an attribute and value column. After unpivoting, the data frame is grouped by the original group by columns and the newly created attribute column, aggregating the values. The final result is a data frame that is effectively unpivoted, showing the attribute and its corresponding total value for each group.